Today, in this video, we will explain about magnetic field produced by long straight wire, circular loop, and solenoid. Magnetic field is a region around a magnetic material or a moving electric charge within which a force of magnetism acts. First and foremost, I would like to explain about magnetic field produced by long straight wire. When there is no current flow through the long straight wire, then there is no magnetic field around it. But when there is current flow through the long straight wire, there is a circular magnetic field around it. Here, I will explain how the magnetic field is produced by a circular loop wire. When an electric current flows through a circular loop of wire, it generates a magnetic field around it. The magnetic field lines are circular near the wire, but as you move away from the wire, the concentric circle becomes bigger and bigger at the center of the loop. Solenoid is a long coil made of insulated copper wire containing a large number of turns. When an electric current passes through the wire, each turn of solenoid is a current carrying circular loop. So, each circular loop is producing a magnetic field around it. The magnetic field of all these turns add up to produce a strong magnetic field of the solenoid. Hi Timmy, what are you doing?
Right now, I'm doing a simple experiment about how magnetic field produced by long straight wire, circular loop, and solenoid.
I still don't understand about the topic. Can you please explain it to me?
Sure, let's look at here. First, we connect a battery to the circuit, so there is a current flow through the wire. As we know that when the current flow through the wire, there is presence of the magnetic field around it. To indicate the presence of the magnetic field, we can use iron powder. So, this is the result of the experiment. As you can see, we can determine the direction of magnetic field by using right-hand grip rule. First, we find the current direction which is inside the page by using thumb. The direction of the grip is clockwise, which indicates the magnetic field direction. So, we move to the second experiment, which is magnetic field produced by circular loop. And we use right-hand grip rule to determine the direction of magnetic field. But we have two cases here. The first one, the electric current flow out of the page, and the second one is the electric current flow into the page. So, this is the result for the second experiment. For the first case, we know that the current flow out of the page, so the direction of the magnetic field will be anti-clockwise. For the second case, we know that the current is moving into the page, so the direction of magnetic field is clockwise. So we can see here, the iron powder indicates the flow of the magnetic field. Okay, for the last experiment, the experiment of how magnetic field produced by solenoid. So the direction of the current is from south to north. We can use the right hand grip rule to determine the direction of the magnetic field. So our thumb need to follow the direction of the current, which is from south to north, and the grip show the direction of magnetic field, which is anti-clockwise. So the iron powder indicate the direction of magnetic field.
As we can see, we can also prove that magnetic fields are present at our experiment by using the Biot-Savart law. The permeability constant is 4 pi exponent negative 7. For long straight wire, using the formula that has been given at the video, insert the information at I, which is 6 ampere, R is 0.03 meter, and permeability constant as usual. So the answer is 4 exponent negative 5t. Secondly, for the circular loop, we can also use the formula that have been given at the slide. Just insert the value, which is I is 6 ampere, R is 0.1 meter, and permeability constant as usual. So the answer is 3.77 exponent negative 5t. Lastly, for solenoid, as usual, just using the formula that have been given at the slide. For I is 6 ampere, N is 1 meter, N is 254, permeability constant as usual, and permeability of a material is 1.0. So, the answer is 1.92 exponent negative 3t.